In March of 1955, Albert Einstein sat down to write a letter. His lifelong friend, Michel Besso, the man he once called the best sounding board in all of Europe, had just died. Einstein himself was sick. He had weeks left to live. And yet, instead of writing something sentimental, he wrote something that physicists have been arguing about for 70 years. He told the Besso family, "Now he has departed from this strange world a little ahead of me. That signifies nothing. For those of us who believe in physics, the distinction between past, present, and future is only a stubbornly persistent illusion." Einstein wasn't being poetic. He was making a physics claim, that your future already exists, that the moment of your death is just as real as the moment of your birth. And if that's true, it raises a question so uncomfortable that most physicists would rather change the subject. If everything that will ever happen has already happened, why does it feel like anything is happening at all? To understand what Einstein was getting at, we need to go back to 1908, when his former math teacher, Hermann Minkowski, stood before a crowd of German scientists and declared that space by itself and time by itself are doomed to fade away into mere shadows, and that only a union of the two will preserve an independent reality. What Minkowski had done was take Einstein's special relativity and reframe it geometrically. He showed that space and time aren't separate things. They're a single four-dimensional structure called spacetime, and every event that has ever occurred or ever will occur occupies a fixed location within it. This is what physicists call the block universe. Picture the entire history of the cosmos, from the Big Bang to the heat death of the universe, not as a story unfolding moment by moment, but as a sculpture, a frozen, four-dimensional object where past, present, and future all coexist. Your entire life is a thread woven through this block, what physicists call a worldline. You don't move through time the way a boat moves through water. You simply exist at every point along that thread, the way a road exists at every point along its length. But why should we take this seriously? Because of one of the strangest results in all of physics, the relativity of simultaneity. Einstein showed that two events happening at the same time for one observer might happen at completely different times for another observer moving at a different speed. This isn't a trick of perception or a delay caused by the time light takes to travel. It's built into the structure of reality itself. If you and I are moving relative to each other, we literally slice up space-time at different angles. My now includes events that are in your future, and your now includes events in my past. There is no universal present moment. And if your future events are already part of my present, then those events must already exist. They're just located at a different coordinate in the four-dimensional block. So if the block universe is real, your tomorrow morning is already out there. The coffee you haven't brewed, the conversation you haven't had, the decision you haven't made. So why doesn't it feel that way? Why do you feel like you're moving through time, making choices, experiencing surprise? This is where entropy enters the picture. The second law of thermodynamics tells us that in any isolated system, disorder tends to increase. Eggs break but don't unbreak. Perfume diffuses through a room but never collects back into the bottle. This one-way increase in disorder is what physicist Arthur Eddington called the arrow of time, and it is the only thing in fundamental physics that distinguishes the past from the future. The basic equations of physics, whether Newtonian mechanics, electromagnetism, or quantum mechanics, work perfectly well in both directions. Play them forward or backward, and the math doesn't care. But the second law does. It gives time a direction, not because the laws demand it, but because of how the universe started. The Big Bang was an extraordinarily low entropy state, highly ordered. Everything since has been a slow slide toward greater disorder. Our experience of time flowing forward is the experience of entropy increasing. We remember the past because recording information is an entropic process. We can't remember the future because, from our thermodynamic perspective, it hasn't degraded yet. This isn't just abstract philosophy. The GPS satellites orbiting about 20,000 kilometers above your head carry atomic clocks that drift by roughly 38 microseconds per day relative to clocks on Earth's surface. That's a combined effect of special relativity slowing the satellite clocks due to their speed by about 7 microseconds, and general relativity speeding them up due to weaker gravity at altitude by about 45 microseconds. If engineers didn't correct for this, your phone's location would drift by roughly 11 kilometers every single day. Time isn't ticking at the same rate everywhere. It's faster on mountaintops than in valleys. The flow of time you feel isn't universal. It's local, personal, and dependent on where you are and how fast you're moving. So if the block universe is real and the arrow of time is entropy's shadow, what are we? Some physicists describe us as four-dimensional objects, sometimes called spacetime worms, stretched from birth to death, with consciousness acting like a spotlight sliding along our world line, illuminating each moment as now. But this creates a paradox. What moves the spotlight? If time is frozen in the block, you can't use time to explain the experience of time. You'd need some second, external time for the spotlight to move through, and then a third time to explain that one, and so on forever. Not everyone accepts the block universe. Physicist Lee Smolin, in his book, Time Reborn, argued that time is not an illusion and that the future does not yet exist. In his view, the present moment is where reality is genuinely being created. Carlo Rovelli takes yet another path. In the order of time, he argues that at the deepest level of quantum gravity, the time variable simply vanishes from the equations. For Rovelli, what we call time is something that emerges from our particular thermodynamic relationship with the universe, similar to temperature. Temperature isn't a fundamental property of individual atoms, but a statistical property of large collections of them. Time, he suggests, might work the same way. Here is what makes this question so maddening and so wonderful. We don't know the answer. The block universe is consistent with relativity. The arrow of time is consistent with thermodynamics. Consciousness remains one of the hardest unsolved problems in science. And the experience of the present moment sits at the intersection of all three, daring anyone to explain it. What we do know is this: the clocks on your satellites tick differently from the clock on your wall. Your now is not my now. And the man who understood this better than anyone spent one of his last letters on Earth insisting that the death of his best friend signified nothing, because in the geometry of the universe, Besso is still right there. If this made you rethink what a clock is actually measuring, drop a like and subscribe for more.